In this video, I'll be graphing the 6 basic trigonometric functions, and then we'll look at the features of each. And this is something you should be able to do. This is a basic skill that you should leave with when you move on to your next course. All right, so for sine of x, first of all, you want to have 4 intervals. So what I normally do is I'll make a mark, and we know our period is 2 pi for sine. And then halfway, you'll make another mark. Of course, that's where pi is. And then in each of these periods or intervals, you can put a mark as well. And so we have 4 intervals, 1, 2, 3, 4. And we're basically using 5 marks to put points at. So starting at 0, this is 1, 2, 3, 4, 5 tick marks. A sine curve starts at 0, and so we're going to start right there at 0, at the y value 0, and then we go up to 1, and then down to 0, then down to negative 1, and back to 1, and so it looks like this. So that would be one period of a sine curve. I'm going to go ahead and go the other direction as well, so we would keep going in the same pattern. So basically down 1, then to 0, then up 1, then back to 0. And it's a nice, smooth, rounded curve. It looks something like that. Of course, this would be minus pi and minus 2 pi. And so notice we're working in radians here. That's what we normally like to do when we do our graphs. All right, so on cosine, very similar to a sine curve. I'm going to come back and do the features later. So a cosine curve starts at 1. Now notice the 4 intervals again. This would be our 2 pi, our pi, and then you've got pi over 2 and 3 pi over 2 here, and of course this is at 0. And so with a sine curve, you start at 1, and you come down to 0, and then down to negative 1, then to 0, and then positive 1. So a sine or a cosine curve looks like this. Now, sometimes people will do a sine curve or cosine curve from negative pi to pi just because it does have symmetry with respect to the y-axis, and you can see that. So let's go ahead and draw that other period or another cycle. And it looks something like that. And again, this is minus 2 pi and minus pi. All right, let's go on and look at a tangent curve. Now we normally like to draw a tangent curve from minus pi over 2 to pi over 2. And the main difference, or the big difference, when you go from sine or cosine to tangent is your period is only pi. It's not 2 pi. And so notice this is pi. And so we should have 4 increments from minus pi over 2 to pi over 2. And so we are going to have asymptotes at negative pi over 2 and pi over 2. And then we know that with a tangent curve, we have an increasing graph, so it's going to go from left to right, it's going to be going up. And we know that at this first interval, we're going to be at negative 1. Then here we're at 0, and then here we're at 1. And so your graph looks something like this. And if you wanted to draw another cycle or another period, we would have another asymptote here. Notice our 4 increments, and we would start here go through that point, and that point there. And it's going to look something like that. All right, let's move on to the cotangent curve. I guess we're doing cosecant next. Actually, I'm going to go ahead and do cotangent since that goes more along the lines of what we just did with tangent. So a cotangent curve actually starts at 0 and it goes to pi. Again, that's one period, and so pi over 2 and minus, or no, that's not pi over 2. This would be pi over 2 here. And remember, you should have 4 increments. So there's one here and a mark there. So 1, 2, 3, 4. So we're going from 0 to pi. That's one cycle. And this would be pi over 4. This would be 3 pi over 4. And with a cotangent curve, it's going to be a decreasing graph. So starting up here, we're going to come down to 1, then 0, and then -1, and it'll look something like this. And if you wanted to draw one more cycle, you could probably do it over here, but I'm going to do it over here just because we're going to talk about symmetry later, and it'll help us to see that. And so we can put one more cycle over here. Notice now we're at minus pi, and this will be minus pi over 2. And coming down from here, we'll go through 1, then 0, and -1. And it's going to look something like that. Now try to be careful when you draw these. This curve should be approaching the asymptote here and also down here. All right, so that's cotangent. Let's go to cosecant. Now for cosecant, the first thing you want to do, remember cosecant is the reciprocal of sine. And so you're going to want to start by drawing a sine curve. So remember, you start at 0, you still go into 2 pi, and there's 4 increments here. We'll start at 0, and then 1, 0, -1, and back to 0. And we're going to make this a dotted line because it's not actually part of the graph. And we'll do the same thing on the other side. All right, so there is our sine curve. Now, wherever we're at 0 for sine, we would be undefined for the reciprocal. So that's where we're going to have our asymptotes. Notice I am drawing 2 cycles here. So our graph is going to look like this. So that would be one cycle from 0 to 2 pi, and we'll do one on the other side. And it looks like that. Last one is cosine, or I should say the secant curve, which is where we're going to be using cosine, a cosine curve to be our guide. So let's go ahead and do that. I should go ahead and put in my points first. Just takes a little getting used to the pattern here, but once you get it down, it's pretty simple to remember. All right, so again, at wherever we're at 0, we're going to have an asymptote. So you can see we have a curve here. These are called branches, or what they call branches. Don't forget you got a little piece right here. It's basically half of one of these guys. And so that would be 2 cycles of a secant curve. All right, so let's go back now, and we're going to look at the features of these graphs. So with the sine graph, first of all, our amplitude is 1. So basically, this is the middle of the curve, and you go up 1 and as low as down -1, and so we call that an amplitude of 1. Our period is 2 pi. Notice the domain. This graph goes forever left and forever right. It just continues on, and so there is no left or rightmost value. So as you look at all these points on the graph, we're literally hitting every x value that there is. Like from here to here, you're going from 0 to 2 pi. And all of these points have values between 0 and pi over 2. And it just keeps going forever. There is no largest or smallest x value, so our domain is all real numbers. So we would say it goes from -infinity to infinity. Then our range, now we're focused on the y values of this graph. Well, notice at the lowest point, the y value is -1. With range, you always want to go from the lowest point on the graph to the highest. And then the highest point on the graph, that is at y, where y equals 1. So notice this is 1, and this is -1. So if you look at all the points on this graph, the y values go between -1 and 1. That's our range. Now, some other things we should mention. Notice this is an odd function, because for any point that you find on this side over here, if you reflect that through the origin, you'll find a point on the opposite side. And so we do have an odd function, which means we have origin symmetry. And if we were to call this function f of x equals sine x, what that would mean is f of minus x is equal to minus sine of x. And that's not hard to see. If I choose an x value here, and you can see the output, the corresponding y values here. If you choose minus x, that's over here. And notice you have the same y value, but now it's negative. And so that's what this is really telling us. All right, let's move on to cosine. So again, our amplitude is going to be 1. The period will be 2 pi. The domain and range are going to be the same. -infinity to infinity. And then the range goes from -1 to 1. Now notice here we have symmetry with respect to the y-axis, or what I call y-axis symmetry. So this is an even function. Excuse me. So we have y-axis symmetry. And again, if we had f of x equals cosine of x, what that means is if you replace x with minus x, you would get the same value. Basically, f of minus x is equal to f of x, or the original function. And again, you can see that if you pick an x value here, notice the y value is there. If you go and choose the opposite value, notice the y value is still the same. And so that's basically what that's telling us. Whoops. All right, let's go to number 3, tangent. So I'm going to go ahead and do my autofocus real quick here. All right, so first of all, you'll notice there is no amplitude. This thing goes up forever and down forever. But we do have a period of pi, so that's different. So from negative pi over 2 to pi over 2, that's a period of pi. Asymptotes are key features of these graphs, and we're going to have them at x equals 2n plus 1 times pi over 2. Well, notice we have one at pi over 2. Basically what this is saying is at the odd multiples of pi over 2, we're going to have an asymptote. So if n was 0, 2 times 0 plus 1, that's 1. 1 times pi over 2, that gives us this one here. If we were to plug in 1, 2 times 1 is 2, plus 1, that's 3. 3 times pi over 2 is 3 pi over 2, and that's where we have our next asymptote. So at 1 pi over 2, 3 pi over 2, notice this is 2 pi over 2, which is also pi. But all to say, at every odd multiple of pi over 2, we're going to have an asymptote. So I'll go ahead and put that. At the odd multiples of pi over 2. Now our domain, excuse me, as you go from left to right, we're actually going to hit every x value except for at these asymptotes. So how do we say that? So basically we're going to use set notation. We're going to say it's all values x, or the set of all values x, such that x doesn't equal 2n plus 1 times pi over 2. So basically we're saying it's all the x values except at the multiples of pi over 2 where we have these asymptotes. Now notice the range, we go down forever and up forever. We're not missing, if you look at all the points on this curve, we hit every y value. And so it's going to be negative infinity to positive infinity. Another key feature here is this is an increasing function. From left to right, we're always rising. So an increasing function. And you should also notice we have origin symmetry here, which means this is an odd function, and we'll just leave it at that. We've talked about those before. Let's move on to cotangent. Now with cotangent, excuse me, things are quite similar. Our period is pi. Notice here we're going from 0 to pi. It's really important when you're trying to identify curves that are either a cotangent or tangent curve that you look at the period. When you see something going from negative pi over 2 to pi over 2, that's tangent curve. When you're looking at something that's going from 0 to pi, we normally would label that as a cotangent curve. Now when you start doing phase shifts, you can actually get a cotangent curve to look like a tangent curve or vice versa, but in general, negative pi over 2 to pi over 2, that's a tangent curve. Cotangent curve goes from 0 to pi. And that's when your period doesn't change. We know that that can change. All right, but we're just focused on the basic graphs right now. All right, so what else do we know about these? Our asymptotes, we're going to have at x equals n times pi. So notice at 0 and at pi, then we'd have one at 2 pi. So they're the multiples of pi. Our domain, again, it's going to be all real numbers x such that x is not at one of these multiples of pi. And our range is going to be all real numbers. Notice this now is a decreasing function. From left to right it's falling, so it's a decreasing function. And you'll notice, if you look carefully here, this is an odd function. Notice this point here reflected through the origin puts you at this point here. This is an odd function, which means we do have origin symmetry. All right, let's look at cosecant and secant next. So first of all, we use y equals sine x as a guide to draw this thing. Our period is the same as it is for sine. It's 2 pi. Notice we have asymptotes, and these are at the x-intercepts of y equals sine x. The other way to say that is at x equals n times pi. Whoops. Notice at 0 and then pi and then at 2 pi. So basically the multiples of pi. Now be careful on the domain here. Again, notice we're hitting all of the x values. If you look at the points on this graph, and then it picks up here, and then it picks up here, and it picks up here, we're hitting everything except for at these asymptotes. And so the way we would write our domain is it's all values x such that x is not equal to one of these multiples of pi. So x does not equal n times pi. The range is negative infinity to negative 1, union 1 to infinity. So basically it's the opposite of what our, or almost the opposite of what our range was for the sine or cosine curve. Remember, it was negative 1 to 1. Now we're saying everything outside of negative 1 and 1, except for 1, is on both. And so you can see that in here, when y goes from negative 1 to 1, there's no graph in here. The y values pick up at 1 and are down at negative 1 and below. Notice this also is an odd function, and that means we have origin symmetry. And I think we'll stop there. Remember, we also call these branches, just for terminology. And then let's do our last one here for secant. This time we use y equals cosine of x as a guide to draw it. Our period, just like with the cosine curve, is 2 pi. Let's look at our asymptotes. Well, they're at the x-intercepts of y equals cosine x. Now, they happen to actually happen at pi over 2. This would be 3 pi over 2. Remember, this is 2 pi here, minus pi over 2 here, and minus 3 pi over 2. So again, it's those odd multiples of pi over 2. And so we would say x is at 2n plus 1 times pi over 2. Our domain is going to be the same as it was for cosecant. All values of x such that x does not equal In this case, though, it's the odd multiples of pi over 2. And our range is exactly the same, negative infinity to negative 1, and then 1 to infinity. You'll notice this is an even function. See the symmetry through the y-axis? And so that means we do have y-axis symmetry. All right, and that's going to be it. That covers all the basic graphs and their key features.